Hello everyone. Today actually, before everything, I want to clear your some doubts regarding reversible process, concept of reversible process, and the maximum work done. I'm discussing again. For that, let me share my screen. I'll show you some slide, earlier slides only. Here we go. See here, the same slide I'm taking. That is explanation of reversible work done. See dear student. The different types of processes have been discussed, may be conducted reversibly or irreversibly. So our concern was regarding reversible process. What is reversible process? First to see the definition. Any process in such a manner that takes place in such a manner that at every stage the driving force is infinitesimally greater than the opposing force and which can be reversed by a slight increase in the opposing force is called a reversible process. So as I came to know, your difficulty was regarding driving and opposing force. So I'll give a bit more emphasis in these regards. What is driving force? What is opposing force? Before I'm telling again, whenever the piston is undergoing compression, mind again, when the piston is undergoing compression, then this internal pressure will be the opposing force and external pressure will be the driving force. Repeating again, at any kind of compression, the internal pressure, the internal pressure is always opposing, and the external pressure is driving. Clear? On the other hand, if you are talking about expansion, whenever piston is coming up, then this internal pressure will be the driving and external pressure will be the opposing. When the piston is moving up, expansion, internal pressure will be the driving and external pressure will be the opposing. Am I clear? At the repeating again, at the time of compression, internal pressure is opposing, external pressure is driving. At the time of expansion, external pressure is opposing, internal pressure is driving. Very clear? Here the confusion took place in that way only, because here whatever presentation I made, that is based on compression, and in the explanation of maximum work done, there I use the expansion. To hope this again, this presentation I'm discussing, and I think this confusion will not exist more. See the now. This is a cylinder having some gas enclosed. It is a movable piston, correct? Initially the piston was at position A, and after compression, let me consider it will come at position B. Very clear? Mind, I'm talking about compression. Now, since I'm talking about compression, this is obviously external pressure, that is external force, right? This will be called now driving force. Why? Because these force is leading the piston to go down, sorry. So this is driving. Now who will oppose at the time of coming down the piston? The internal pressure will opposite. That is what the concept of opposing force. See, this is internal pressure, which I've written. This is the opposing force. Is it clear now? This is driving and this is opposing. Had it been expansion, again I am telling, expansion के time ये pressure, external pressure होता था opposing, and the internal pressure would have been driving. Very clear to everyone? Fine. Next come to the concept. When it becomes reversible, when the piston is coming from A to B, when it becomes reversible. Mind, if the piston is coming from A to B suddenly, fast step, in a single step, that will be always called an irreversible process. Irreversible process. कभी जब piston A to B suddenly आएगा, fast आएगा, single step में आएगा. Very clear? See now. Piston is coming up. It is single step process, fast process. Let me think. Let me see the data. Here, when piston was at A, जब piston A पे था, then internal pressure and external pressure was exactly suppose same 1 atm, and that is why piston was stable here. Whenever internal and external pressure same, then only the piston will be right static at one place. So let us consider that was at position A, जब internal and external pressure 1 atmosphere था. Now what I did, suddenly I increased the external pressure to atmospheric pressure, up to 2 atmospheric pressure. This was one initially. Suddenly अगर ये increase हो जाएगा 2 atmosphere, तो obviously piston will come down, right? But it will come suddenly, because what I have done, I have increased the external pressure by 2 atmospheric pressure suddenly. Clear? So this will be an irreversible process, mind, fast process, and that is why it is irreversible. Got it? Now my concern was what, when it will be a reversible process, right? Pay attention, please. Next time, let me consider while the piston was at A, no doubt. Then obviously internal pressure, external pressure was 1 atm. This time I need to bring the piston from A to B, but not by a single step, right? Not by a fast process. How I want to bring? Suppose the piston was at A now. I increase the external pressure not directly to, but 1.0001 atm. You understood? Piston was here, 1 atm, 1 atm. I increase the external pressure by 0.0001 atm. Then now see, piston will come down, no doubt, but it will come so minimum, that minimum distance it will move, that it will be almost negligible, because pressure difference is very minimum. Okay, now these 1.0001 atm atmospheric pressure, if external pressure is made, the piston will come very minimum distance down. And what I am doing, this way, every time, see the data here, every time I increase the pressure by 0.001 every time. Initially it was, in the first step it was 1.0001, next again increase 1.0002, 1.0003. These way I am increasing. Now you think what will happen? Whatever movement of the piston will be there, that is there, but it is so minimum, so less, that you will not be able to actually practically distinguish. Got it? Since you are unable to distinguish, then you will think, piston is not moving. But now do one thing. This kind of steps is done, suppose hypothetically think, ऐसा करके step I have done 1 million times. I have done 10,000 times, suppose. So after making these changes, this way, this small difference is made up to 10,000 times. Then after after certain long time of period, obviously piston will move up to B, no doubt. But every time, in every step, what was the movement? That movement was so minimum, that so less, that you are unable to distinguish what was initial and what was the final state. Tell me, understood or not? Repeating again, whenever piston was at A, internal and external pressure was exactly 1 atm, piston was stable. Now I am increasing the external pressure. How much I increased? By a very negligible difference. This is the external pressure now, increased by an infinite decimal amount as compared to internal pressure. So piston will no doubt come down, but you will not be able to measure exactly because it is very minimum, right? It is negligible. But these negligible difference, these negligible changes you make around 10,000 times, 1 lakh times, then what will happen? After long time, after infinite number of steps, that 1 lakh time of steps involved, and finally the piston will come at B. Got it? Now the point is that each and every time, whenever I increase the pressure from 1 to 1.0001 atm, then time what you told, the difference was so negligible it cannot be measured. Got it? So every time you are telling the difference is so negligible it cannot be measured, but after series of steps, infinite number of steps, ultimately that appreciable change has been occurred. That amount of change has been made. Means you are carrying out the same compression A to B, no doubt. Carrying out the same compression A to B, no doubt. By this way, involving some infinite number of small steps. What is the advantage of involving that number of steps? That minimum steps, that infinitesimal small steps will lead the system, will keep the system equilibrium always with the surroundings. Means there has to be equilibrium in each and every steps. So this is the prime criteria, this is the main criteria of a reversible process. Whenever the process is taking place, रिवर्सिबल प्रोसेस का मेन क्राइटेरिया होता है जब एक रिवर्सिबल प्रोसेस हो रहा है, then every time, right, the system has to be in equilibrium with the surroundings. Since the equilibrium is what? The mean difference was initial and final was so minimum that you are unable to find it, means the initial and final were in equilibrium, they are balanced. And how it was decreasing then? It was decreasing in this way. This way. Tell me understood or not. So this is what the process. Whenever this kind of minimum differences is made between driving force and opposing force, each and every steps that will be very much negligible. These way you do millions of times, and whatever after the doing that millions times of changes, you will get an appreciable amount of change. The same change as you made in case of, as you got in case of fast process, irreversible process. But here, infinite number of steps are involved. System is always at equilibrium with the surroundings, and this kind of process will be always called a reversible process. Mind, it is no doubt a hypothetical concept, an ideal concept, but it has got a big importance in this thermodynamics. So better you have to understand in this way. No doubt, practically it may not be possible, but it makes our thermodynamic very easy to understand. Here you see, finally, I have made increasing, I have made the pressure up to 1.999, and finally it is up to 2 atm. जब 2 atm में आ जाएगा, piston will be stable here as we did last time. Same process we did suddenly, but here it has not done suddenly. Infinite number of millions of steps are involved in this process, and these involvement of millions of steps, no doubt it will take infinite time of completion, but this kind of process will be called a reversible process. Is it clear? So based on that, the next reversible process, the criteria, I just want to sort out it again. Hold on. Here it is there only. Features of reversible process. Whatever I told, everything will be there. See now. This is features of reversible process. मतलब reversible process होने के लिए क्या क्या होना पड़ेगा? The driving and opposing forces are infinitesimally different from each other. Next, the process can be reversed at any point during the process by making infinitesimal change in conditions. As I told you, it is means the difference was very less, very minimum. So it can be reversed at any time. But the process is this, then it can be this at any time, any point of time. The process takes place in infinite number of steps. Very true. At the end of each and every step, right, the process must attain, the system must attain the equilibrium. Maximum work is obtained during the reversible process. I was talking about these actually reversible process. I told you will not understand here. Then after I Today also I just will write. I'll give you little idea about this also. The process takes place so slowly that the system is always in temperature, pressure equilibrium with the surrounding. Nothing but that is mechanical equilibrium, what you can say. Fine. On the other hand, irreversible process, I told you in that contrast to that only. It is a fast process, right? A process which is not reversible called irreversible. It's a very simple statement. The difference between driving and opposing force will be large difference. As we did, it was 1 atm initially. Suddenly I made opposing force 2 atm. It came down. External force I made, driving force I made 2 atm. It suddenly came down. Okay, so that was fast process, irreversible process, because difference between driving and opposing forces at the time of compression I'm talking, driving and opposing forces are large. That is why it is a fast process. All irreversible process, this repeating this statement, all irreversible is the correct statement. All irreversible processes are spontaneous process, and all spontaneous processes are natural process. Means in the nature, whatever processes are taking place, all are natural, all are spontaneous, all are irreversible. Thus, there is a statement, all natural processes are irreversible processes. Is that clear to everyone? Irreversible process is simple, very fast process, single step process, right? No equilibrium is involved during the process. Fine. Equilibrium will involve at the very beginning and at the end. In between, you don't expect any kind of equilibrium. Okay. And all irreversible processes are natural processes. All natural processes are spontaneous. So all spontaneous process has to be irreversible. राइट तो कभी भी जब स्पॉन्टेनियस प्रोसेस का बात आ रहा है हम क्या सोचेंगे वी आर टॉकिंग अबाउट इरिवर्सिबल प्रोसेस राइट विल डिस्कस दिस थिंग एट लेंथ you have to understand it well कि natural process spontaneous processes are always irreversible. Am I clear? Now I shall bring you back to another slide. That was the concept of maximum work done. You will understand now. See here, the same slide I brought. Concept of maximum work done again here. Reversible work done is the maximum of that statement. The rate statement you remember now in the characteristic of reversible process. Same thing. Here the piston. Here the process I was talking about expansion. I think that actually will that was you were a bit confused regarding that. Here I was talking about expansion. This is A. This is A. Now the piston will grow from A to B. So at the very beginning of this discussion, I'll tell you if the piston is going from A to B. Now, can you tell me which one is the driving force now? Which force is leading the piston to go up? Mind, that is the internal pressure. Now it is driving. And who is opposing? Who is against this? It is external force. External pressure. External pressure is the opposing here. So there should not be confusion. Again, I am telling at the time of compression, internal pressure was opposing, external was driving. At the time of expansion, now I am talking about here expansion. Here the internal pressure is driving, external pressure is opposing. Okay. In case of compression, repeating again, internal pressure was opposing, external was driving. Here at the time of expansion, right, internal pressure is driving, external pressure is opposing. Very clear. See now the next. Internal pressure 2 atm. Okay. Then external pressure has to be just to keep the piston stable here. Internal 2 atm, the external has to be 2 atm only. Now I'll decrease the external pressure so that now only piston will go up. यहाँ पे internal pressure 2 atm है, external pressure भी 2 atm था, that is why piston was stable here. अभी मैं क्या करूँ, external pressure को कम कर रहा हूँ, तो obviously piston will go up, right? See now, this much distance has to be traveled A to B. Explanation 1. Internal pressure obviously 2 atm. external pressure P external, and extent of work done. Okay, now see, internal pressure which is driving this is 2 always, external pressure जो opposing था, suddenly I made 0 atmosphere. यहाँ पे opposing force को मैंने 0 atmosphere कर दिया, तो obviously piston will suddenly move up it from A to B, very fast process. But although the piston is moving, but no work will be done, because you know it is a condition of free expansion. In the free expansion, external pressure is 0. So you know the formula, minus P external into delta V. That was the work done. Minus P external, mein P is 0 here. The entire work done has become 0. So this is what no work is done. Got it? Now think, I made external pressure 0, so no work was done. Now I want very little work done. Expansion is A to B, but I want very little work done. That means the external pressure has to be slightly more than 0. It is very close to 0, because had it been 0, no work could have been done. But I want very little work done. So what I have to do? External pressure should be slightly more than 0. Let me consider the data. That data is that pressure, external pressure is 0.0001 atm. Right? It is not 0, but slightly more than 0. Internal pressure is 2 atm. Now what will happen? Here also piston will suddenly move up, but you will get very minimum work done. Why very minimum? Because external pressure is very less. No external pressure, no work done, very little external pressure. So very little work is done. Is it clear to everyone? Now slowly I'm doing the same expansion. A to B मुझे expansion करना है. Next time, what I have done, the external pressure is made, suppose 10 times more, like 0.001 atm. So whatever work done I'll be getting 10 times more work done, right? No doubt here also the very little work done will be obtained. But as compared to earlier one, 10 times more work done will be obtained. Here the statement, little more work is done. Got it? External pressure 0, no work done. External pressure very less, less work done will be obtained. External pressure little more work done will be obtained. Am I right? See now. So another 10 times increased. Even more work done will be obtained. Got it? Now these way I'm increasing the external pressure. Piston, the same process A to B, but external pressure in different right experiment with higher and higher external pressure. I am carrying out the same process. It means I am getting little more and more work done. थोड़ा थोड़ा करके मुझे ज्यादा work done मिल रहा है. Now question is, at what maximum amount of work done, right? At what pressure we can get the maximum amount of work done. प्रेशर को मैं इंक्रीज कर रहा हूँ, इंक्रीज करते करते कितना ज्यादा इंक्रीज कर सकता हूँ, so that work done will be the highest. See now, these way increasing, work done is increasing. Very simple. Now I increase the external pressure now up to 1.9999 atm. Mind it, it is the highest amount of external pressure I can increase. Because if you increase little more, it will be exactly 2 atm. Then piston will be again stable here. I don't want that. Even you cannot increase these more than 2. If you increase it more than 2, then process will be reversed. Expansion will not take place. Instead, what will take place? Compression. I don't want compression, because from the beginning itself I'm talking about the expansion process, not the compression. Got it? It means, what is the condition, you know? This pressure has to be maximum, but infinitesimally less than the internal pressure. This is the condition. And in that case, since this pressure is highest, this external pressure is maximum, so what about the work done produced? That means maximum work done is obtained from here. Is it clear? Very simple idea. You see my calculation, go through my slides, you will understand very well. Keeping internal pressure 2 atmosphere only, in different experiment, the same expansion you carry out, but under different external pressure. External pressure 0, no work will be done. External pressure very little, expansion is the same, very little work done will be obtained. This way you increase the external pressure, and you increase up to the maximum extent. And maximum extent कब होगा? जब internal pressure से infinite decimally कम होगा. My best example was this. Internal pressure अगर 2 atm है, then external pressure I can increase up to 1.9999 atm. That is called they are differing by an infinite decimal amount. Very clear? And then time. These expansion will take long time, infinite time for completion. In this condition, infinite number of steps will be involved, and thus the process will become reversible. And since the process has become reversible, so the work done is how much? Work done is maximum. So is it clear to everyone? Just try to understand it again, right? It's very right, concrete ideas given in terms of this data. So hope you'll understand this time without any confusion. So that is the concept of maximum work done. And in the next slide, what I did, it is a formal explanation. That explanation like how we write in examination. We have W equal to minus P. This is the formula we know. I think this is easy to understand. If the pressure P of the gas differs from P external by quantity delta P, then P minus P external is delta P. It is the internal pressure, external pressure, driving force, opposing force. It is the difference between them. That implies P external is this, so I can replace in that way. P external is removed from here, right? This is this P external, I told you last time also. P minus delta P delta V. Now see the logic, forget about negative sign. The magnitude of W will be maximum if this value of delta P is minimum. ये जितना कम होगा, ये W का मैग्नीट्यूड उतना ही ज्यादा हो जाएगा, राइट? ये बहुत कम होने का मतलब क्या है? The difference between internal and external pressures is very less, बहुत कम. That means they are differing by infinite decimal amount, and that leads to the process. What kind of process? Reversible process. So in that case, maximum work will be obtained. From this calculation, it is evident that maximum expansion work is obtained, is obtained from the system only when the force that opposes expansion is infinitesimally smaller than the driving force. Driving to 2 था, opposing, right, will be infinitesimally less than the driving. मतलब ये अगर 2 है, ये होगा 1.9999. Clear? But this is exactly the condition defined for a reversibility of a process. Hence, it may be concluded that maximum work is obtained from a system when any change taking place in it is thermodynamic reversible manner. So hope this concept is clear to everyone. Now I have to come back to your, as usual, next discussion. And before next discussion, what I shall tell you, what I told you the last time. First of all, I discussed about path dependence of work and heat. You know, we are talking very much about state functions, many right thing you got. But as far as path function, non-state functions are concerned, two examples are very prominent. One is heat, another is work done. And you came to know work done depends on path, whether it is free expansion, irreversible expansion, or reversible expansion. The amount of work done will be different. That means work done depends on path, right? The same thing does not happen with temperature, pressure, volume, etc. Okay. Next path dependent factor was the path dependent function was heat. Heat also depends on, right, two different paths. One is isothermal path, another is adiabatic path. The isothermal path, where heat is allowed to transfer between system and the surrounding. Then time we write Q not equal to 0. But in adiabatic process, what happens? Q equal to 0 because no heat is allowed to, right, transfer between system and the surroundings. So that was the concept of path function we discussed earlier. Next, sign convention regarding, positive sign always comes when system's energy is increased. Negative sign always comes when system's energy is decreased. I'm talking about if W is plus, work done is plus, then what you will say? Surrounding is doing work on the system. If W is minus, system is doing work on the surrounding. Similarly, sign convention of heat, if Q is plus, surrounding is giving heat to the system. If Q is minus, system is giving heat to the surroundings. Very clear? Then after I discussed about unit of work like is three basic units. Basics unit will be discussing like joule, SI unit, calorie, right? And then very important unit which is right frequently used in thermodynamics is liter atmosphere. I told you how liter atmosphere comes, right? W equal to P into V, pressure and volume. So pressure is atmosphere, volume is in liter. So then we saw the conversion factor of liter atmosphere and joule. You have to remember the data. 1 liter atmosphere is 101.325. Yeah, 101.3 joule. That's all. The next is coming about some numericals. I taught you what kind of two varieties of numericals that can arise from this much discussion. Once there was confusion between which formula is to be used. I think you remember, right? W equal to minus T delta V or W max equal to minus 2.303 nRT log of V2 by V1. इनमें से कौन सा use करोगे? I told you in that one example I took. In that example, I told you whenever in the numerical there is one statement like expansion against a constant pressure or compression against a constant pressure, that is always an irreversible process. You have to apply the formula W equal to minus P external delta V. Very clear to everyone? Next discussion was very important internal energy. I was talking internal energy means I gave you one very important example. I asked you to remember also. Whenever any body, any wooden body, I gave example, was taken to the center of the earth. Why center of earth? Because their potential energy will be perfectly zero, as well as if it is static, kinetic energy will be zero. At that place, hypothetically, you think practically not possible anyway. At that place, you are telling the total amount of energy of the body will be zero because potential energy and kinetic energy both are zero. So total energy has to be zero. Okay, but think once, at that point, at the center of earth I was talking about, if I burn the body, then what will happen? You will get sufficient amount of heat energy. You will get sufficient amount of light energy as well as some sound energy also. But you told total energy is zero. Then how this amount of energy has been generated? And energy is cannot be created, right? Some way it has to be there in that body itself. ये जो एनर्जी रिलीज हुआ ये तो क्रिएट तो नहीं हुआ ना. From that body itself the energy somewhere it was associated. This amount of energy which is not included in your so-called potential, so-called kinetic energies, that amount of energy is associated inside the body with the atoms, with the molecules, and that amount of energy is always called an internal energy. It's a very important concept to understand what is internal energy. Correct? It comprises then what were the things? Kinetic energy between the molecules. Electrons are moving. They have some motion. They have some kinetic energies. Kinetic energies are all the particles, right? Electrons, molecules, atoms. Potential energy associated with the electron, right? Proton, then nucleus, then what you can tell atom to atom, molecule to molecule, all the attraction forces, all the repulsive forces, they comprise the potential energies. ये सब मिला के हम क्या बोलते हैं, उसको इंटरनल एनर्जी बोलते हैं. Very right. This is already been discussed at length. Next was coming the first law of thermodynamics. I told you, even it is known to you, everyone, it is a very simple statement. Energy, it is the conservation of energy. Energy is conserved, right? Neither created nor destroyed. It can be converted from one form to another form. Anyway, this is the first law, different statement we have seen. So all the statements you have to remember, these normally asked in board examination. You write the different statements of first law of thermodynamics. Then after it was mathematical expression. Mathematical expression was very easy. A proper expression is there in the slide, right? So delta U equal to Q plus W. Delta U is the change in internal energy. Q is the amount of heat. W is the work done. Right? This formula itself means for a system, if you change either heat or work done or both, that will directly reflect in its internal energy. Another important thing I told you, as far as internal energy is concerned, the internal energy is comprises so many things which are right, so many things and so much complicated things. You cannot determine, you cannot find out internal absolute value of internal energy, right? The symbol u value is never found because of whatever component, whatever right things it actually comes from. Those things are very difficult to calculate, very difficult to measure. But we are fortunate enough, thermodynamics never asks about the absolute value of internal energy. It always deals with the difference, and difference can be determined very easily. As you know, the formula, mathematical formula, first law itself explains very well. Change in internal energy, mind change, is nothing but summation of heat and work done. Now heat is added or removed from the system, work is done on the system by the system, that will decide whether internal energy of a system will increase or decrease. Is it clear? Fine. Now next, whatever slide is coming, dear student, I shall tell you. After that, numericals were done. See now, this is the next topic, modified first law of thermodynamics. Now question is, whatever first law of thermodynamics we have learned, there is some confusion, some drawback, and question is, what is that drawback? Okay, just to explain that, you might have heard about one thing, that whenever any nucleus is broken, like uranium nucleus I'm talking about, a tremendous amount of energy is released. There is a nuclear fission. Now question is that whenever any uranium nucleus is broken, tremendous amount of energy is released. Question is, from where that energy is generated? Because once the nucleus is broken, if you exactly count the number of protons, number of neutrons, number of electrons in all the fragments, whatever have been found, is exactly same, right? Number of particles will be exactly same. The answer is, whenever any nucleus is broken, tremendous amount of energy is released. From where that amount of energy is released, that exactly comes from the binding energy. Now question is, what is binding energy? See, inside nucleus is a very small unit inside an atom, and in that nucleus, large number of protons which are exactly positively charged, they are combined together, they are associated together. Actually they should repel, and they should repel with tremendous force, but still all the protons are very uh, closely spaced, and that is why so many numbers, uranium In uranium, 92 protons are there. All the 92 protons are associated together inside the nucleus. Question is just to keep all the protons together. Which force is acting? That force is binding force. You will come to know, already have come to know in nuclear chemistry, that whenever a nucleus is formed, certain amount of mass is converted into energy. कभी भी जब न्यूक्लियस बनता है ना, तो न्यूक्लियंस का जो मास है, सर्टेन मास, थोड़ा मास एनर्जी पे कन्वर्ट होता है, and that energy makes the nucleons bind together. Already you came to know in nuclear chemistry that is called binding force, binding energy. Got it? Now particles are combining together, mass is converting to binding energy. That energy will help the particles to associate together. Now you are telling you don't want the particles to be associated, you are breaking it. It means whatever amount was used to make them bind together, that amount will be released. Sorry. That amount will be released. And this is the amount of energy that releases during breaking of nucleus, breaking of nucleons. Got the idea? So that energy is actually coming from binding energy. And how the binding energy is coming? From conversion of mass into energy. Got it? Now think back about first law. In the first law, it was only written, only energy is convertible. Means one form of energy disappears, exactly same amount of energy will reappear. But here in this concept, what we found? Mass can be converted into equivalent amount of energy. अगर certain mass disappear होता है, then equivalent amount of energy will reappear. Surprisingly, right, is very clashing. Right, both the statements are very contradictory. First law के हिसाब से energy is conservable. If one form of energy disappears, another form of energy will reappear. But in this nuclear concept, what I discussed, कि mass can be disappeared and equivalent amount of energy can be reappear. Right? In the first law, they never accept energy can be generated, but here energy can be created. Here energy can be created at the cost of mass. This is the point of modification. I think you understood. So this, based on this theory, the most prominent statement actually that comes from Einstein's that great equation, you know, E is equal to mc square. E is equal to mc square. It is very important equation. This equation is only used to convert amount of mass into energy. That is why it is so famous equation. C. Mass and energies are equivalent and they are mutually interconvertible. Not only energy, mind. This mass and energy equivalence is expressed by Einstein's equation. That is E is equal to mc square. You know, E is the energy, m is the mass, c is the velocity of light. Very right. So this is the only equation which you will be able to find the relation between mass and energy. If certain amount of mass is disappeared, how much amount of energy released will be generated, you can calculate using this equation. Correct? See now, whenever mass of matter decreases in a particular process, a definite amount of energy must be released. Means mass will disappear and you will get the energy. This statement introduces an apparent limitations on the first law of thermodynamics because energy can be produced by the destruction of mass. That is what I told, which first law does not accept. Right? Means energy here can be created, can be generated at the cost of mass, by the destruction of mass. Therefore, the principle of conservation of energy may be replaced by the principle of conservation of mass plus energy. So that is the modification we are doing. फाइन। तो पहले क्या था, सिर्फ एनर्जी लेके कंजर्वेशन था। अभी हम क्या करेंगे, नॉट ओनली एनर्जी, मास एंड एनर्जी बोथ आर कंजर्वेबल। गॉट इट? सी, the first law of thermodynamics may be modified as, see the statement, the sum of mass and energy of an isolated system remains constant. Clear? एक isolated system का not only energy remain constant but summation of mass and energy both remains constant. Clear? That is the modified form. We introduced mass with energy of also. Sorry. This statement shows that one form of energy may be converted into another form and mass may be converted energy, but the total mass plus energy must be constant. Very logical statement now. One form of energy may be converted into another form and mass may be converted into energy also. But here you will get to see total mass plus energy will be always constant. So this is the modified form of first law. I think everyone understood. First law thermodynamics various processes. Very simple discussion. See, isothermal process means in this isothermal process, how the first law of thermodynamics will be modified. For an isothermal process, since temperature remains constant, so internal energy of the system must be constant. This is a very important statement you have to remember. If in any process temperature remains constant, internal energy also will remain constant. That is delta T equals to 0. Therefore, delta is also equal to 0. Now I'll bring back the first law. You know this. Here I'll make this into 0. Then what will come? Either Q equal to minus W or W equal to minus Q. Mind, you might be thinking mathematically they are same, but the thermodynamic meanings are different. Q equal to minus W और W equal to minus Q मैथमेटिकली सेम है, लेकिन थर्मोडायनामिक मतलब एकदम अलग होता है. देखो क्या होता है. Q equal to minus W implies that, see, you will understand, here Q is plus, मतलब heat is absorbed by the system. Here W is minus, means heat is removed from the system. Work is done by the system on the surrounding. Heat is absorbed and work is done by the system on the surrounding. It means in an isothermal process, if you apply certain amount of heat, in an isothermal process, if you apply certain amount of heat to the system, the entire amount of heat will go to work done. But that heat is entirely used to do work done by the system on the surroundings. Clear? कभी भी जब एक सिस्टम आइसोथर्मल प्रोसेस में एक सिस्टम को हीट करोगे, पूरा के पूरा हीट किसमें कन्वर्ट हो जाएगा? वर्क डन. वर्क डन में कन्वर्ट हो जाएगा मतलब द सिस्टम विल बी डूइंग वर्क ऑन द सराउंडिंग्स. क्लियर? द अदर स्टेटमेंट से here W is Q positive, W is positive, Q is negative, means you are doing it opposite. You are doing some work on the system. Suppose you have done 20 kilojoule of work on the system, right? You are the surrounding. Apne, right? You have done 20 kilojoule of work on the surrounding. Extremely sorry. 20 kilojoule of work on the system. Then according to this statement, the entire 20 kilojoule of work done will convert into heat and will given back to the surrounding. Repeating, if you do some work on the system, if surrounding is doing some work on the system, then entire amount of work done will convert into heat and will be released by the system to the surroundings. Clear? So W equal to minus Q implies that in an isothermal process, the work done on the system by the surrounding results in release of heat by the system. Clear? तो यहाँ पे हीट अप्लाई किया, आपको वर्क डन मिला एंटायरली. यहाँ पे आपने वर्क डन किया, आपको हीट मिला बैक. फाइन. So this was the first law of thermodynamics that is modified in isothermal condition. Next, let me see what happens in adiabatic process. See now, adiabatic process, you know, Q will be equal to 0. So directly let me place Q equal to 0 here. No heat is allowed to come in or go out of the system. First law of thermodynamics, delta equal to Q plus W. Let me place it here. Q ka value 0. Then what the equations coming? W equal to delta equal to W, or minus delta Q equal to minus W. You might be thinking similar way, mathematically they are same, but their thermodynamic meanings are different because we have some sign convention. So you have to go by that. See the statement here. Is plus, delta U is plus, as well as W is also plus, right? That implies that in an adiabatic process, the work done on the system by the surroundings is entirely used to increase its internal energy. Very simple. In an adiabatic system, if you do some work on the system, because W is positive, if you do some work on the system, the entire amount of work that will be converted, its internal energy will increase its internal energy, right? Because internal energy also positive, means system's internal energy is increased. The opposite one, here W is negative. What does the negative means? Means system is doing work on the surrounding. System is doing work on the surrounding. But where it will get the energy? That energy has to come from internal energy of the system. But the system ka internal energy will be decreased. That is in the proper statement we can tell. In an adiabatic process, the work done by the system on the surroundings is entirely at the cost of system's internal energy. I think you understood. Adiabatic process. In adiabatic process, the system is doing work on the surrounding. How it will do? It needs some energy. Where it will collect the energy from? From its own internal energy, from the system's internal energy. Clear? So this is what the case with the two meaning of two different statements. Next, isochoric process. You remember isochoric process means delta V equal to 0. So let me modify accordingly. In an isochoric process, the volume remains constant throughout the process. Delta V equal to 0. First law of thermodynamics, delta U equal to Q plus W. Okay, W I can replace in this way, minus P delta V. Correct? Now, as we told, isochoric process delta V is 0. To enter this term will be 0. See now what is coming. Either this is delta equal to Q minus P delta V. Fine, that is okay. Since delta V is 0, then I can write delta equal to Q or minus delta U equal to minus Q. Got it? This term is repeated anyway. Either delta equal to Q or minus delta equal to minus Q. Now I think you will be able to tell the meaning. What does it mean? First you just try. Delta U plus Q is plus. Means in an isochoric process, if you apply some heat to the system, plus means you are applying heat to the system. The entire amount of heat will use to increase its internal energy. Fine, see the statement, it will be clear. Delta equal to Q implies that in an isochoric process, heat supplied to the system is entirely used to increase its internal energy. Next, delta equal to minus Q implies that in an isochoric process, heat released by the system to the surroundings. मतलब system से surrounding में heat release हो रहा है. But where it will get energy from? That is at the cost of internal energy. That is why the internal energy is decreased. Got the idea? So these are the scientific statements actually from these mathematical equations we can make in this way. They normally comes in examination, both entrance as well as in boards. So you have to remember it accurately and you have to understand it. If you understand, it will be easy to remember. Note, if a chemical reaction is carried out in a closed container so that the volume of the system is constant, delta V equal to 0, in such a case, no work is involved and the heat absorbed or released is denoted as QV. It is called heat absorbed or heat released at constant volume. Fine. And very importantly, you see one thing. This is the heat absorbed at constant volume, and which is nothing but that heat absorbed constant volume is equal to delta U. In our earlier discussion, today only I told you, this is non-state function and this is a state function. Now question is that how a non-state function can be equal to, how a non-state function can be equal to a state function. Fine. Statement is that this heat absorbed at constant volume, this volume is designating the path, defining the path. Means this heat absorbed is carried out in which path, that path is mentioned. Mind. Is talking about only one path. Means there is no question of any other different path. The path is fixed. That means this QB is nothing but a state function, not a path function. See the statement. Since U is a state function, so QB is also a state function. Reason is, question is, why it is a state function? Because heat depends on path, no doubt, but you are telling, you are mentioning the path. So it is, path is now immaterial because you already mentioned. The question of following other path is eliminated. That is why heat absorbed at constant volume, you have to remember, is a state function, not a path function. Then the last process I'm discussing today, the isobaric process. If it is applied in first law, what happens? Obviously, practically nothing it happens. See now, delta P is 0. And you know, in first law, there is no place of delta P. First law thermodynamics, delta equal to QP plus W. QP is, right? Just to show it is QP, it is QP. Wi replaced minus P external delta B. Simple equation. Delta equal to QP plus W. W is minus P external delta B. Next, the most of the chemical reactions are run in open container under constant atmospheric pressure. Very important statement, repeating again. In the laboratory, whatever reactions you're carrying out, right? Whatever reactions you carried out up till now, the test tube was open, beaker was open. It means whatever reaction is carried out, their atmospheric pressure is exerted, and which is 1 atm, 1 atmosphere. It means all the reactions you have carried out in the open vessel only. It means all the reactions you have carried out are under constant pressure. Clear? See the statement again. Most of the chemical reactions are run in open container under constant atmospheric pressure. Because the reactions carried out in open containers under constant pressure are very common in chemistry, a special symbol is used, which is delta H. Very importantly, it is called enthalpy. मतलब यहाँ पे जो QP देख रहे हो ना, this QP, it is nothing but so important that we'll designate it by a new term that is called delta H, which is called enthalpy. Mind, in our foregoing discussion, everywhere enthalpy will be present. So that is how enthalpy appears in thermodynamics. So dear students, hope you understood everything. First of all, I cleared your earlier doubts. You go through again my slides, right? Another thing importantly I'm telling again and again, try to write down all the slides in our notebook in details. It will be a perfect notes. Most of the things are written how you'll write in examination. Got it? Remaining the numericals, the theoretical questions you have to write and you have to ask your doubt in our doubt solving session. Fine. So anyway, I think this slide ends here only. Another statement, it is I will understand. Changes given for the heat changes produced in such a reaction. Hence, in order to discuss thermal effects of reactions run at constant pressure, it is convenient to define a new state function called enthalpy. What you told, what already we discussed. QP is nothing but enthalpy. Okay, then for today I'll stop here and see you again with some new topic of this part, thermodynamics.